Good morning, everyone. Today we will explore a new TryHackMe room called Registry Persistence Detection. This room allows us to inject code into Windows Registry, ensuring that our chosen software or code runs automatically upon machine startup. So now let's start the machine on TryHackMe as we explore the room. So I'm going to start the machine right now, and then we can explore. So, this room is going to teach us how malware persists in the machine and also how malware use the registry as persistence mechanism. And then we can also learn how to use AutoRuns PowerShell module to detect remediate persistence mechanisms. So we wait while the room is up and then we can continue. So the term malware persistence can be defined behavior that enable malware to remain on the system regardless of system events such as robots. And there are also multiple ways malware can gain persistence. These techniques use vary depending on the targeted operating system, each of implementation level of steadiness, or sometimes based on the preference of the malware author. Examples of these techniques will be modify an operating system boot sector, installing malware, malicious configuration, or hijacking execution flows. So in Windows, the most common, easiest to implement technique is the abuse of Windows registry run keys. And then we have these four keys in the Windows. The Windows registry is database of low-level operating system and application settings. The run keys are specific keys within the registry that contains a path that runs every time a user logs on. And these are the listed below. These are the directories we have to check in the registry. We have the current user, which is run. We also have the local machine, which can also be placed as run. And it means when the current user logs in, it's going to run automatically. And the local machine, when any user logs in, it's going to also run automatically. So we also have another one which is called run once. This run part when the current user logs in and then delete. It just runs just for once, as you can see. And also on the local machine means when any user logs in. So the current user is more like administrator, while the local machine is any user, just like a public sector. So now we're gonna be exploring the registry on TryHackMe. So here's it, and here's the part which we need to follow. We have the current user, and under the current user, you can easily navigate to a software, and then we go to Microsoft, then we go to Windows, current version, and here we are. No, I don't think this is it. The current version. And then we should also look for run. Yeah, run and run once. So these are where the software might actually be, or this is where the configuration might be. So we have it on run, and then do we? Yes, run. Okay. Yes. So what's the question now? What's the value name of the suspicious registry entry that runs during startup, including the parentheses? So we are under the current version, we are under the run. What is the name? The value name. We can see here, value name. Stafford. Oops, that's correct. What is the value data of the suspicious registry entry during startup? The data. Okay, so we're looking for the data. And I just realized I'm actually in the wrong directory because here we have local machine and I'm currently on the current user. So now I have to navigate back to the local machine instead. So this is the local machine. And then we go now to software. And then after that, we go to Microsoft. Then we get the current version under the Microsoft. Oh, Windows first. Windows and then current version. Okay, now we have it. So this is the default, the name, and then we should also have the data, value not set. That's going to be on the run. Run. Okay, so this is the value data. What is the value data of the suspicious registry entry that runs during startup? So here we have the data. So I'm going to copy this and let's see, should be this Control C and submit. Okay, now the answer is correct. Then what string is displayed on the console when the suspicious file runs? I think we have the console here. It's already running immediately the room started. And then what was the display? The display is please let me persist. Let's see. I have to close it, then also I have to find it back in order for me to know what exactly is the display. So it's not running again, then we have to look for it, the file. I think it's let me persist, but then we can run it from my computer. Let's see. This PC, we can go here, program file, user, administrator, app data, and the local. You know, we are on the local file, local machine, like this local machine. So let's see, BD 84. And here we go. So what is the string, or what string is displayed on the console when the suspicious files runs? So this is the suspicious files, and the string displayed is please let me persist. Please let me persist. So that's the correct answer. Now on to the next question. You can also check out the tools and read me. Oh, this is GitHub. And then what AutoRuns function is used to getting the display, for getting and displaying the AutoRuns entries? Okay, use get help, cmd let with AutoRuns command to answer the question. So I think we're going to use PowerShell right now. Yes, Windows PowerShell. As you've seen in the previous tag, it's possible to detect the existence of persistence mechanism in the registry by manually checking keys. However, other registry keys can be used to establish persistence and they are not as obvious, making them harder to find. Fortunately, some tools can help us with this problem, like AutoRuns. I think we've done that already in TryHackMe room. Then we also have the 6 internal rooms on TryHackMe. We've also done that as well. So if you haven't, I would advise you to check these rooms out on TryHackMe. So let's go. Okay, let's see with the command, get command. Mine is AutoRuns. Okay, so let's see. Okay, so these are the functions, these are the command, and then this is how you can input it. Get help. Then you have to include these functions in it. So, okay, I think I even made a mistake with my previous command. So let me see, let me try again. Okay, here we go. So we have these three functions already, and then we can also get help by checking them manually. Let's get help, and then we can include this. AutoRun baseline. Okay. So here we go. And what is the question here? What AutoRun function is used for getting and displaying AutoRun entries? Now I'm going to check the help for the three, and then we can find our answers easily. We had the first one, which is comparing AutoRuns, and then let's see the second command. Now we have the second one. I'm going to run the third one and then go back to the question. So here we go. Now, what AutoRun function is used for getting and displaying AutoRun's entry? And then we can see here, retrieve a list of program configured to auto start boots. No. Compare to baseline files of AutoRun artifacts. No. Let me check this. Getting and displaying the AutoRun's entry. Creating a baseline file from AutoRun artifacts. Creating a baseline file as a PowerShell script, PS1 file. For getting and displaying. Okay, this is it. Get AutoRun's entries. For getting and displaying the AutoRun's entries. So here we are. This is our answer here. So that's gonna be get PS AutoRuns. So let's check this. Okay, that's correct. Which function is used for creating a baseline files from AutoRun's artifact? To create a baseline, we can even see it here. New AutoRun baseline. But let's check it out. This is it, creating a baseline file from AutoRun's artifact. So this answers the question. And the third one, which autorun function is used for comparing two baseline files of autorun artifacts? I think I read that earlier. So let's see the function. This is compare autorun baseline. It's already written there, but also you can also check, always check to confirm, of course. Okay, this is it. Comparing two baseline files of autorun artifacts. So here gives the answer as well. And that's it. So moving on to the next chapter. Now we have to do this. Okay, let me follow this command. And out grid view. Oh, this is good. So what do you have to do here? Now wait for a couple of minutes for the tool to finish populating the results. The result above lists all possible place a program can run and start up. You can filter this result by specifying the keyword in the filter bar at the top. So here we can always filter here. And according to the previous mentioned category, open a new PowerShell window and use get help command to the list available parameter. So I'm gonna open a new one. And then let's see. Yeah, it's coming up. So we're actually using the out grid view to extract it for easy reading. So you can read it easily, more like on the PowerShell terminal. So now first let me use this command, minus help, and then detailed. Okay, now we have a lot of information. And then let's answer this question with this information. What perimeter switch is used for filtering for artifacts related to boot execution of images? This is the keyword we're looking for in here, boot execution. Boot execute. We have it. This is the switch parameter for boot execute. Let's see if that is correct. Oh, that's correct. How many entries are outputted using perimeter switch from previous question? Using perimeter switch from previous question, then that is when we have to do this. 1 sec. Get. I hope this works. I'll get PS AutoRuns. One sec. I think it should work. Yeah. What is wrong with this command? So we can do that by running this command: get ps autoruns dash boot execute. Then what's the question? How many entries are outputted using the perimeter switch from the previous question, which is boot execute? So we have only one input here. So that gives us 1. Correct. What perimeter switch is used for filtering artifacts related to printer, driver, and status monitor? Okay. I'm going to run this command again. So for filtering artifact related to printer driver, if I'm actually using a Linux, I can easily use grep, and I can grep it out, but this is Windows PowerShell. So now I need to look for printer driver. Okay. Okay, we have something. I think it's printer monitor. Let's see if this is it. Okay, that's correct. Then how many entries are listed in the outputs using the parameter switch from the previous question? So we have it's now we have to run this command. For the print monitor. So how many entries are listed in the output using the perimeter switch from the previous question? How many output do we have here? 1, 2, 3, 4, and 5. We have 5 outputs. Let me see, is that correct? Oh, that is correct. So what parameter is used to add a new column to show whether a file is digitally signed? We need to go back up and check if the file is digitally signed. This is the keyword. Remember, guys, we have the previous one for the related to printer driver, and also this boot execution. And then now we have a file is digitally signed. So let's look for something related to that in our PowerShell. Digital signature. Let's see if this works. Okay, that's correct. So searching our categories, how many entries do we have the signed column set to false? We have it in here. Specify the very digital signature parameter while calling get ps autorun to get the signed column. Okay, so now as for this, we need to check the ones on the column which is set to false. Let's do it in the we can do this in 2 ways actually, but then let's look at it from here. Now it's going to be specifically for the room. Now we're going to verify. This is the last one we've not checked yet. So then we have to check this. Verify. Sorry. Digital signature. And then we can part this out grid view. What was the question? Searching all categories, how many entries have the signed column set to false? So this is the signed column. And by clicking this sign, you can rearrange the column more like if you want to put it in orderly form. If it's like a date and the date is not arranged regularly, you can actually click the column and you can see it filter itself. So let's see this. I'm clicking the sign now and see if I have something. Okay. Now we have empty, 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 and then we have false, false, false. So searching our category, how many entries have the signed column set to false? 1, 2, 3. So this is a 3-column set to false, and yes, let's do this. But first, try to answer the previous question with just PowerShell and without using outgrid. So they advise us not to use this. Like we should use the PowerShell command instead of using this signed column. So, and I'm not sure yet if the answer is 3, but we found 3 here. So now I'm going to navigate back to PowerShell where we can try this command, not outgrid. Then we have it where object signed dollar signed and equals to false. Uh, do we have a command? Do we have a given command? I think we've got this function, but now we did this already, but for this, we should check out the function. The term signed is not recognized. So guys, I think I made a mistake with my command. So this should be okay now. Let's wait for it while it runs. Okay, so how many do we have which is false? The still running. That's 1, 2, and 3. So I think that is the correct answer. So this completes this room. Without using out the grid view, we can also use the command to find how many entries have signed column set to false, which is 3. So that's correct. And now let's get here to this room now. What do we have to do? While filtering via parameter switch help reduce the output, there's still a lot to go through. The baseline creation of comparison feature of AutoRuns PowerShell module is helpful, as only entries that differ from the baseline are chosen in the result. After creating the room machine, a baseline file was generated to save the document folder, and this serves as snapshot of the registry before the malware ran. So let's see this on my computer, this PC, and the document. We can see we have the file here. So to check what registry key change, a new baseline file needs to be created using new auto baseline function. So we need to create a new baseline. And now let's use this command. Verify digital signature. Okay. And then where is OS binary. Then now creating a new auto-run baseline. Bubbles. Okay, let's see. Let's wait for it to run. The two baseline file cannot be compared using the following command, but let's wait. It should have a new auto-run baseline that we should be able to find that on my PC. Not yet. Still running. Okay, now we have it. So now what was the task? Now we should have two baseline files now. Yes, now we have two. You can see this one is created 10th of December 2023, and this was the previous one, which was 2022. Okay, so now we have to compare both baselines with this command, compare. Both and how to review. Yeah. Okay. There's another suspicious logon registry. What is the full path of this key? So we have a suspicious log on registry. Let's try and check this. Can we copy? I don't think so. Then I think we can do it manually. That is okay. We can find it here on the registry part, Windows, and local machine. What was the name of the registry again? Software, Microsoft, Windows NT current version, and WinLogin. Let's check this. Microsoft, Windows entry. So I'm still looking for the parts here. I have it on PowerShell. We have a full part. Windows NT, current version, and WinLogin. So Windows NT, current version, and WinLogin. Yes, we have a WinLogin here. So what was the file we are looking for? We are looking for this file, this item, user init. Yeah, because it has a TryHackMe room. So it looks suspicious and funny. Then we should check it here. User init. And here we go. So there's another suspicious login entry. What is the full part of this key? Now the parts, we have the part already. This is the part. The part should be here, the software. Oh no. Okay, let's see. But they asked for the full part. So we can check that up with this HKLM, double colon, and slash software. HKLM, double colon, and slash. Do we have that correct? Okay, good. Now, what is the value item name of the suspicious registry entry from question one? The value name. Now we found it here, and this is the value name, user init. We can easily copy that. Correct. And yes, what is the value data of the suspicious registry entry from question one? The value data, yeah, we have it here as well, value data. Oh, that's correct. So what is the category that AutoRuns assigned to the entry from question one? The category. We should be able to see that here. Category. From the grid view, out grid view, we have the category logon. Okay. Oh, I need to restart this machine. 1 sec, please. Okay, let's see if I can complete this. What is the string? What is the displayed on the console when the suspicious file ran? What is displayed on the console when the suspicious file ran? So then with this, we can run it manually from my PC, local PC, and yes, user, administrator, app data, local. We have the THM because we're looking for the THM file, and then here comes the suspicious file. So, what are you going to display? Let me stay my friend. Okay, let me stay my friend. Oh, and that's it. And conclusion. So we have everything correct right now. We can now take the necessary step to remove the malicious registry keys and files we found. In this case, it is easy as deleting or modifying entries via regedit and ensuring that they are gone after a reboot. So we can delete them, we can modify them manually. So guys, I hope you enjoyed today's room. And if you have any questions, please put it on the comment box. And there we have it. We have successfully navigated the Windows directory, utilized PowerShell command, and conducted essential security checks. Feel free to ask any question or explore further on your own. Thank you very much.